Hi everyone, Steve Goodwin here with anchor test video number 132. This really should be considered a continuation of my previous test, and that was in video number 108. In it, I fully tested this 45-pound Mantus M2 anchor, and what I discovered was the potential flaw. Well, there's definitely a flaw in the fluke, the way it was manufactured, and there was the potential that it was causing the anchor to not behave as well as it could have if it was built nice and straight. Now, for those that haven't seen video number 108 or my other Mantus M2 video, that was with this 17-pound Mantus, I'll do a real quick rehash of what led to this. So first of all, I tested a 17-pound M2 and it did just wonderfully. I won't say perfect because all these M2s are not wonderful in the soft mud, but otherwise the little 17 M2, it really impressed me. It just stayed upright, didn't want to roll out, made nice holding power, just was excellent. So then a couple weeks later, it came to the 45-pound version, and I was expecting it just to knock it out of the park, and it did not. There was two obvious areas where this anchor was flawed, and the big one was in the sandy mud veer. In that test, if I veered in one direction, it would work one way, and if I veered in the other direction, it behaved completely different. And what it was, if I was veering that direction, meaning the anchor was rotating to starboard, it would pivot okay through 180 degrees, but then the straight line portion, the anchor had a lot of motion, it was listed, and most disturbing, it would never realign with the direction of pull. It stayed sort of at this cocked off angle, maybe about 5 degrees, lifted up, all the shank showing, and the anchor just was moving along happily, well, maybe unhappily, at a half a knot or so, and that's unacceptable. If you veer to the other direction, no problem. Stayed put, very little motion in the straight line portion, and all was happy. The other thing that it did that was odd just out there on the water is every time the anchor came up from the bottom and it had mud on it, the mud was only present on this side of the fluke right here. Never mud on that side. It didn't matter if it was a straight line pull, a veer one way, or a veer in the other direction, mud only on one side. And the trailing edge of that mud always coincided with this little jog or flaw in the fluke. So, and what this flaw is in manufacturing, the forward half of the fluke is a casting. It includes the slot area, and then the rear half of the fluke is plate, and those two pieces of metal are joined together, they're welded, and for whatever reason it just had misalignment problems. In that other video I showed you, I put a straight edge on here, we see a large gap, we see misalignment, there's maybe a 1/8 of an inch a bit of out of plane. Other side is better but not great. The 17-pounder, it's nice and straight, both sides, very symmetrical, and I surmised that this flaw could have been the cause for that performance issue. So then we fast forward to just several weeks ago, and as you know, I conducted that big shootout with all the 45-pound range anchors in the same sandy mud seabed, but this time using the high pulling winch, up to 5,000 pounds, and the very best anchors could peak that 5,000-pound resistance number and stay upright and stay engaged. Really, the king of that test was the 45-pound Vulcan anchor. Just really excellent. And this anchor kind of has a similar arrangement, you know, a single tall fluke, no roll bar, concave design. Yeah, I would have expected a nice upright pull, but it wasn't the case. It was a little bit erratic. It did touch the 5,000s once in that test, but it spent a lot of time at lesser holding, actually varying up and down. At one point it did roll out completely. So again, it was more erratic than I was expecting, and I just thought, aha, here's more evidence that my kinked fluke theory is correct. So at that point I thought, all right, we got to get to the bottom of this. Where I work at my day job, I have access to a 60-ton press, and I figured I could just press this fluke back into shape. So I emailed Greg at Mantus Anchors asking for his blessing, and I need that because whenever anybody submits an anchor for testing, the promise I make to them is that I will not modify or molest the anchor without their permission. So I asked for that, And Greg shot me an email right back, and he just simply said, how about if I send you a whole new anchor to test? And I thought, great. And here it is. So right out of the box, the very first thing I did was put my straight edge on it, and it's nearly perfect. Just a tiny little gap, maybe a 64th of an inch. So let's just call it perfect. Now I know what you're thinking. You're thinking, aha, Greg cherry-picked his stock and he sent you a perfect anchor. Not the case. What he did was he changed the way they build the anchors. And it's not just this one. I verified it with him. The whole line of M2 anchors is now built different. Rather than the forward part of the fluke or the casting ending here, and then it turns into the plate portion, and here is a line, let's call it 2/3 of the way back along the base of the shank. Now that joint occurs at the front of the base of the shank, way up here. Now the casting underneath still extends all the way back because the slot is still a casting, but there's sort of a shelf cast into the forward portion on which the plate can bear on, and that distance of that shelf is, well, gosh, I don't know, maybe 6 inches. And what I believe is going on here is it would just be impossible to misalign it now. They've sort of built in a feature that pretty much ensures proper alignment. Now, I did not ask Greg why he did this or if my theory is correct about this alignment thing, but I'm virtually certain that that's the case, that this was done to make this anchor more manufacturable to a higher tolerance. Now, you might also notice a slight difference in the way the toe is shaped. On the old anchor, this sort of crease continues all the way forward through the casting, all the way to the tip of the anchor. But on the new version, there is sort of a flat spot here. Now, that maybe makes the tip a little bit heavier, and that's a good thing, and maybe a little bit stronger. That's good too. But it's pretty small, negligible amount of material, and I can't really see how it would affect the performance either. So I don't pay too much attention to that. The real story is that we now have straight symmetrical flukes. So let's get out onto the water and see if the test will show that this anchor goes from an excellent design to a superb design or not. Okay, we'll start off with the sandy mud Veer. This was the test where there was that glaring flaw in the way that original flawed anchor kind of kept moving in one direction of this test. We'll start off with a port direction, and in that direction, the flawed anchor did well. And it's the same story with this anchor. The 180-degree pivot is just that. It is a pivot with almost no motion. Doesn't really get any better. We are watching this at 8 times playback speed. Just keeps the video short, and frankly, you can see relative motion better when things are happening a bit faster. Now we're into the straight line portion, and once again, just like that flawed version in this port Veer, it's great. There's almost no motion. It really doesn't get any better. And now for the next try, this time we will go in the starboard direction. And this was where the flawed anchor had its troubles. But we're going to find that this anchor doesn't have it. It's just the problem seems to be solved. And I'm going to say that the change to a symmetrical, correctly built fluke has improved the anchor. There's very little doubt in that. I did execute several tries with the flawed anchor, and I never could get the anchor to straighten out and quit moving. But this one, right out of the gate, no problem. We see a near perfect Veer. And then here in the straight line portion, the anchor does not rise up. We assume the anchor stays upright, and there is very little motion right up to and holding this boat's maximum thrust of 1,325 pounds. On retrieval, we see the mud falling away, and in fact, topside here, we see no mud packed into either side of the fluke. Okay, next is a holding or resistance check here in the sandy mud using the winch. This apparatus can pull the anchors for 90 feet, and I did conduct 4 complete deployments and tests for the new unflawed M2. The first deployment here was a long hover at 3,000 or in the 3,000 pounds, but with a peak of 4,000. Now that's a really good result, just not excellent. The anchor is capable of reaching up to about 5,000. We did see that once with the flawed version, and again, my theory or my hope was that this anchor, being nice and straight and symmetrical, would be able to repeat its sort of best pull numbers over and over, but it wasn't the case. This first deployment, it was a hover in the 3,000s with a peak at 4,000 and no release. Here's the second try for that winch resistance test. It was similar to the first. This time the peak was 4,100 pounds. Unfortunately, the anchor rolled out. We didn't get to see it because the camera had plunged under the seabed. But here we have the anchor moving along slowly, not aggressively at all, and the tip of the anchor is well above the seabed, and it is not resetting. I think the ear of the anchor has penetrated the seafloor, and what you see is what you get, no reset. Here's the third try, and for this one, it was a peak of 3,700 pounds. However, the anchor stayed upright and did not release. That was the full 90 feet, stayed engaged, and behavior was just perfect. And for the fourth and final pull, the anchor had some more variable results. Initially, it had a hover in the 3,000s. Then the anchor released. We didn't see it because the camera had plunged into the seafloor, but I believe it was a rollout. It did reset, however, and then had the greatest resistance of all 4 of these pulls. It touched 5,000 briefly. Now, my overall assessment here is that there was no change between this new non-flawed M2 versus the other version. So no change here in the straight line test. Here's some shots of the new M2 in the clean sand Veer test. Probably wasn't really necessary to do this test here because the original flawed M2 was very, very good here, just almost perfect, and it's just the same thing here. So I'll just go through these real quick. We're watching at 8 times speed. The boat's veering to starboard on this one, and not a lot of motion. The anchor's just pivoting right on around. And straight line portion, it's real good. Not a lot of motion, right up into the maximum that the boat can pull. Never see any part of the anchor throughout this whole pull. I assume the anchor is upright and doing just great. Seabed sloughs right off the anchor, and topside, we don't see anything on the anchor on this one, just a spotless, clean fluke. Here's the other pull here in the clean sand. This time the boat will veer to port, and it's the same story. Real good results. Not a lot of motion during 180 degrees of veer. And on the straight line portion, again, not a lot of motion. So anchor does not appear to be affected at all in this seabed by that fluke flaw from that other anchor. I just assume that this less cohesive sand just tends to flow around irregularities more readily than that more sticky, cohesive sand over in the sandy mud. Once again, the anchor cleans itself just right away on the release. Did get one little dab of seabed there that remained after the retrieval. Last test was in the soft mud seabed. Once again, probably didn't need to do this, but I was out and about and wanted to be thorough, so I gave the M2 another try. The reason I'm skeptical that it was going to do better is because none of the M2s, even the perfectly built 17-pounder, did particularly well here. The story is just low holding power. They behave fairly well. They don't roll out. They stay mostly engaged. But again, not a lot of holding. The protocol for these 45-pound range anchors is to pull them with 500-pound baseline. Can't even do it. The initial set really had to be held at 400 pounds. After the Veer, though, I did increase thrust, and it held a little better, so perhaps it screwed itself in deeper, and it's maybe slightly better than the flawed M2. Here's a look at the updated 45-pound range anchor ranking chart. The Mantus M2 did improve a bit. It's up a couple notches overall. It's as a result mostly of that sandy mud Veer. It was formerly a 3, now it gets a 5. The only other tweaks I made was in the sandy mud resistance. It's a 4.5 instead of a 5. And then it went up a little bit in the soft mud holding. Went from a 2 to a 2.5. Well, I think Mantus should be commended for the changes they made to the way they build these anchors. I'm certain that it's going to result in their tolerances improving. Now, did it change this anchor from an excellent performer to a superb one? Not quite. I do believe it is better in that Veer test. There's a degree of more stability, but we saw in the high-power winch test, it still has a tendency to roll. There's only one good theory that I have, and unfortunately I didn't think of it. I wish I could say I was the smart guy, but it was actually one of you viewers. They noted that these shanks are bolted to the flukes off to one side. The bolt actually forces it over to one side of the slot. These slots are cast and, not terribly precise, so they have to make it a little oversized. The result is a clear passage of water all the way through the anchor. That ruler's making it all the way to the table. The other side, no gap at all. Now, we know from my previous experiments that when we drill holes in the fluke, the anchor performs better. You get better resetting, better holding, less mud sticking to the anchor. Maybe the gap is acting like a hole in the fluke. The problem with the theory is that every time I retrieved this anchor after a test, that gap was fully packed with sand or mud, and I'm not really sure how that would still, if it would be effective as a whole, if it's packed full of seabed. Maybe moisture can still pass through there. Maybe I need to do another test with that gap filled completely with a caulking of some sort. But until they do that, that's all I have for now. I'm Steve Goodwin. So long.